this week, we had the midterm examination. I have uploaded the solution sheet that I used to grade your midterm examination. And I also shared the form of the exams that I'm expecting. And we started with the 10 true-false problems, and half of those comes from the problems that we already discussed in Q&A, and most of you did very well, but some students lost these problems and some others. And Mr. Kim Min-jae asked why this is false. And some of other students, Mr. Chu gave an answer that this subset is an element of this power set. So S is an element of power set, not a subset of power set. And etc. And Morgan's law for logics for quantified propositions is given. For a real number, such as a negative real number, then there is no smaller natural number which is smaller than the negative real number, so this is false. And all others are true. And I asked you in part 2 to state more than 10 discrete math terminologies and definitions and concepts that you have learned from the first 5 chapters. And most of you did very well on this. That include the GCD, LCD, Bezos theorems, Euclidean algorithms, and compositions and relations, injective function and surjective functions, and big O notations, and omega notations, and theta notations, and many. And also, the part 2 includes the problem that asks you to state 10 things that you can do after you studied the first 5 chapters of discrete mathematics. And many of you did very well on this too. Some students who only wrote 5, and I gave only 5 points for those students who told that he can only do 5 instead of 10 things. And the part 3 asked you to give a sketch of a proof. And those problems, half of those problems from the problems that we discussed in Q&A. That shows how series can be represented as a big O notation and big omega notation and theta notations. And simple examples that tells us the convergence speed of the sequence, and give a sketch of the proof for this series and the theta notations. And one question related to GCD and Euclidean algorithms. And find the product of GCD and LCM. Actually, that's just a product of 2 numbers from the theorem that we have learned. And I gave one problem in chapter 2 that shows the existence. There's no there's no smallest positive rational numbers, and we used a proof by contradiction on this. And one example asks you to do the modular exponentiation. So instead of multiply 11 times on 8, you can do only 4 times to have the same answers. And Euclidean algorithm, extended Euclidean algorithms was used to solve these problems. And one coding problem was given, and how this code can be made, the pseudocode can be completed in Python-based language. And also, I assigned 20 points, as I told you in the syllabus, to check your online and offline attendance and your participation. And also I used this page to make your team members, which was finalized today because none of you made any claim on your team so far. And I gave 1 point of bonus problem to you. I think that was the midterm exam that I made as I promised before the exam and in the early in this semester. Okay, any questions on your midterm examination? I showed you and I distributed your graded midterm examination. So if you find anything, then tell me in the break. Okay. If you have no question, we will continue the chapter 6. Any questions?